Hello learners, welcome to Education Online program. I am teacher Willa Lucia. So today we are going to learn about linear motion. So this will be our topic for today. Linear motion, sometimes you find it being called a rectilinear motion, meaning that motion in a straight line. So when we are talking about this linear motion, we are talking about motion in straight line. So how do you find this motion in straight line? Let's take a look at let us take a look at a particle at a position x, or we can say a person, an athlete running 100 meters. What does this athlete do? How does 100 meters look like? You find out that it is from one point and just a very straight line, which is 100 meters. So you see that to move from that point up to from the point X, from where the athlete is starting up to the next destination, to the end of the 100 meters, there is a time interval that this athlete also takes to reach that point. So our linear motion has been divided into two. We have the uniform linear motion, and then we have the non-uniform linear motion. We have it here, the types of linear motion. We've talked of uniform linear motion. If this is the type of the linear motion, when do we acquire this uniform linear motion? We acquire this uniform linear motion when the body is moving at a constant velocity. So if it is constant velocity, that means that it is having a zero acceleration. So what of the non-uniform linear motion? A non-uniform linear motion. With a non-linear motion, these are motions that take place not at a zero acceleration. So we see that they have a variable velocity. For this one, they are moving at a constant velocity, then uniform. But if you come to the non-uniform, it is moving at a variable velocity, and the acceleration there is non-uniform. So you see that with motion, when we come to motion, there are so many terms we use. With someone who has not been introduced to science or physics, they talk about going slowly, going fast. But then when you now come to physics, we add more vocabularies to those, and then you end up with things like displacement, distance. We talk about the speed, we talk about the acceleration. So as we go deep into linear motion, you'll find out that these terms are widely used there. So for us to continue with it, we need to know each and every term used in linear motion by defining them, and then we have to know what units do they carry. So those are very important, because you will reach calculations where you need, at the end of the day, after calculating, the value that you get needs to carry a unit. So what unit will it be carrying? We shall all see that. So we shall start with the terms used in motion. Terms used in motion. So what are these terms that are used in motion? Because if you see that space, you can have space for one point, maybe there is me standing just here in front of this whiteboard here, the space between us here has got a name. So we can call it a distance. So that is a term used in motion. So we can have one as distance. How would you define distance? So we can say distance is just the space between 2 points. Just like I said before, me standing in front of the whiteboard, there is some distance in between us. There is this empty space. Before, if I want to touch this, then I have to come closer to it to have a direct contact with it. But when I leave it right behind me, that space there is what is known as the distance, because it is between me and that. I am a point and the whiteboard is also another point. So we can say our distance is a space between 2 points. What could be the unit of distance? Distance is measured in meters, and also distance is a scalar quantity. It doesn't have a specific direction because it is just a space, barely space. So space does not have its own direction. So this one here, the SI unit becomes is meters. So let's look at another term. We shall also be using terms like displacement. What is this displacement here? This displacement here is the distance moved in a specified time. So that means that if you move this distance, if this distance from me to the whiteboard here has been measured, or I am moving from my point here up to this point as I'm going backwards, I am taking some seconds to reach the whiteboard there. So I am covering this distance in a specified time or specific time interval. So that means that I am being displaced from my original position to another position. So we can say displacement is the distance covered in a specified time. Is the distance covered in a specified time interval. So these two will be used every time, everywhere. As you go deep into motion, you're going to be seeing this. Another thing we shall be seeing is the speed. Another term here is speed. You see, when people are driving, as they move, you will see that the traffic police will be like, the speed is, your speed is too high, you need to reduce the speed, the word. So what is this speed here? We can define our speed as the rate of, it's the rate of change of displacement, or a rate of change of the distance with time. Let's write it here as rate of change of distance with time. So you see our speed here, it has the whatever, it has the magnitude, because if you look at it, it has also the direction it is taking, because it is changing the rate there. So we are saying that this one has a unit. Did I give it? I have not given it the unit of displacement. Sorry for that. So displacement is measured in, let's first write that unit. Our displacement has SI unit, is also measured in meters. So now we can write our speed here. So our speed is the rate of change of distance. So when you're moving from one point to another, changing that distance in a specific time, so it becomes our speed. So we have another time which is known as the our term, which is the velocity. But before we reach the velocity, let's talk about the SI unit for this speed here. The SI unit of speed is our speed is measured in SI unit is meters per second. So our speed is measured in meters per second, and because we are saying it's the rate of change of distance, and we know very well distance is having only the size, it doesn't have its direction, which qualifies also our speed to be a scalar quantity. It doesn't have a specific direction it takes. So how do you find this speed? You'll find out that because of this term rate, we have already a factor of time there. So to find speed, we shall have our speed is equals to distance over time taken. So it's like moving from your home to maybe to any nearby trading center. What happens is that there is distance you're going to cover. For you to get the speed you've used or the speed you walked with, so you're going to get the distance. How far is this place? So when you measure up this distance and then divide it by the time you reached, from the time you started your journey up to the time you reach there, that is how you get the time interval. So when you get that, you divide that distance you've moved by the time you took to reach that trading center. So if you do that, you will get the speed. You'll know what speed you used from your home to the trading center. So we have another term known as the velocity. Velocity. So our velocity here is the rate of change of displacement. So as displacement is changing, that means that the velocity is being changed. As you're moving from one point to another, you're changing the velocity. So we can say our velocity is the rate of change of displacement. So our velocity can be measured. You can get the size of that, and then you also know that it has the direction. So meaning that our velocity becomes a vector quantity, and then it has a specific SI unit. But the unit of velocity is the same as the unit of speed. So it is also carrying SI unit as its SI unit is meters. Meters per second. But then when you look at this velocity here, velocity in motion, it is being divided. It has very many types. So what are some of these types of the velocity? So let us see all the types of this velocity as we go on to other types of other terms used in motion. So let's look at this. Since we have reached velocity, let's check some types of velocity here. velocity has types like we have the initial velocity, we have final velocity, we have things like the average velocity. So we have so many of these. There is non-uniform and there is uniform velocity. But let's take one at a time. Let's look at the initial velocity. What is this initial velocity? As we move on with motion, the letter we are going to give initial velocity is u. So when you see in a physics question and they are giving you u, maybe they have written something as u is equals to 2 meters per second, they are meaning the initial velocity. So we are giving it letter u, mostly it's written as u. So what is this initial velocity? The initial velocity we are talking about here is the velocity that the body starts with from rest. If the body was at rest, so you want to start moving the body, what is that velocity the body was first acquiring? So it is the velocity the body acquires, the body has when it was at rest. So we can write it there as, we can write it as to is the velocity with which a body starts motion or starts to move. What is that velocity if the body is at rest? When the body is at rest, you see that when it's starting to move from that point, the velocity it had was 0. So it is starting to move from a velocity of 0. That means that for a body at rest, our velocity, our initial velocity here, u, will be, our u will be equals to 0 meters per second. So this one is when the body is at rest and it's starting to move. What if you have a question like this? A body, you have a question like saying, maybe a body starts moving with a velocity of 20 meters per second. So the body is starting to accelerate, to move from that point of rest with a velocity of 20. That means that our initial velocity there, our u, will be equals to 20 meters per second. So generally with initial velocity, it means the velocity that the body starts moving with. If the body was already moving at a velocity, starting the velocity at 20, so that one is our initial. So if it is starting from 0, from a point it wasn't moving totally, it becomes also the initial velocity, which becomes the 0. So we have another one here as we have the final velocity. Final velocity. What is this final velocity? And it is mostly given letter V for final velocity. So how would you get this final velocity? So we say that this final velocity is a velocity with which a body ends motion for a given time. So if we've given motion, if you're moving this car, the motion has to end at a specific time, and you're stopping your car. So you're stopping your car with that velocity at which with which you're stopping the car becomes your final velocity. So we say that our final velocity is a velocity with which an object ends motion with time. So as you're stopping this motion, as you're braking your car, that means that you're now taking the car to a final velocity. You're bringing it at rest. So this final velocity here, how would you get your final velocity? When you're bringing this final velocity, when you're bringing your car probably, or the body, you had given it a velocity. When you're bringing it to rest, that means that your final velocity there is 0. So the SI unit for this final velocity still remains the same. It is meters per second, or sometimes it is given in kilometers per hour. So what you do is you can convert it from kilometers per hour to meters per second. So we also have another type of velocity, which is known as the average velocity. Average velocity. What is this average velocity here? This average velocity is just adding the value of the initial velocity and the final velocity, then dividing it by 2. So there you're getting the average between the two velocities. So we shall have it as our initial velocity, which is written as u, plus the final velocity, which is v. You divide it by 2. There you will be getting your average velocity. We have so many of these. We also have what is known as the uniform velocity. So with uniform velocity, we say that it's the rate of change of displacement with a constant, when the displacement is constant. So when you're constantly changing this displacement here, that means that you're going with a uniform velocity. Let's take a look at this example here. Under a uniform velocity. So if someone is saying a car traveling with uniform velocity of 20 meters per second, what happens with this uniform velocity here? If a car is traveling with a velocity of 2 meters per second, if it is uniform velocity, meaning that our final velocity is equal to the initial velocity. That is when the car is moving with a uniform velocity. Meaning that here, our u will be, if our u is 2, our v will still be 2 meters per second. Because at uniform velocity, we have the 2 equaling to each other. So we have what is known as the non-uniform velocity. We say that it's the rate of change of displacement. This is when the rate of change of displacement is not constant, meaning that when the body is moving with a non-uniform velocity, that means that our initial velocity is not equivalent to our final velocity. So that is a lot about the velocity, because during calculations as we go ahead, we shall find that we need to find initial velocity, final, or the average. You will find the terms like uniform velocity, so we needed to know what they are. So let's go back to the terms here we are still using. We have the last term we use as the acceleration. Acceleration. So we find out that acceleration is the rate of change of what? Is the rate of change of velocity. Is the rate of change of velocity. So predict that when you want to get the acceleration, what do? Since it is the rate of change of velocity, if you know the final velocity, and then you know the initial velocity, you know the time taken, you can get your acceleration. So meaning, since it is the rate of change, let's see, we shall have our acceleration, it is always abbreviated as A, is equals to the change of, okay, well, let's have it change in velocity over time taken. So that means that we have our A is equals to our change in velocity. We have the final velocity and the initial velocity, because from where you're starting your journey, so that is how it looks like. From where you're starting, from where you're ending the journey is our final velocity, and where you started the journey, the speed you started the journey with, is the initial velocity. So when you subtract the initial velocity from the final velocity, it will give you, and divide it by time, it will give you the rate at which you were accelerating. So how was your car accelerating? You need to know the time you're taking from one point to another. You need to know the speed you started with, and you need to know the speed you ended with. So you just subtract the speed you started with from the speed you ended with, and divide it by time. Then you get the value of your acceleration there. So acceleration can be positive or it can be negative. How does acceleration become positive? So acceleration becomes positive if velocity is increasing. So as you're moving, as you're maybe pedaling your bike, so as when you're increasing the velocity with which you pedal it, that means that you're increasing you're giving a positive value to acceleration. So what if you're now reducing that? As you're reducing your velocity, you're giving it a negative sign. So because you're now taking it in the opposite direction, that's when you get it as negative. So when acceleration is negative, it can also be called as the retardation. It is still acceleration. If it is retardation because it is moving in the opposite side. So it is either retardation or deceleration. So when you hear deceleration, don't get confused. It's the same as retardation. So today we've seen a lot about motion, the terms we are going to be using as we continue with our lessons, as we go deeper into linear motion. These are the terms we shall be using. And don't forget about the abbreviations we are giving them, the letters. Because like the initial velocity, instead of writing it in full, you just abbreviate it with letter U. They will know it is initial velocity. Likewise to the final velocity, instead of writing the whole thing, you can just give it letter V. Because we are going to see when we are some other equations of the motion, it will not be giving you final velocity in full like this, but then it will just carry the letter V. So you shouldn't get confused of the letters. You should get to know them, and then know the SI units, because every time we calculate, we need to know what units we are going to give the measurement we are getting. So with this, we've come to the end of our lesson. We shall meet again in the next lesson with more in motion.